Alright, hey guys. So today I'm going to do a quick video. Well, I'm not sure how quick it'll be, but I'm going to do a little video of just my workflow using Go inside of Emacs. What I'm trying to do today is just parse this input file down here into this struct type, basically. Now I'm not sure that this is going to be the most useful type for the output, but it's a good place to start. So basically what I'm doing, I tried running one of our old Fortran programs on a very large molecule this morning, and while I was waiting for a very long time for it to finish running, I got inspired to try to write my own version in Go. So this is basically going to be a translation program. I'm going to be translating from Fortran to Go for the most part. I have successfully done this before for one of our Fortran programs, and I achieved a speed up of like 20 times, I think. Hopefully I'm going to be able to do that again. This Fortran program is much more complicated, so I'm not sure I'm going to get to finish it today, but I've been meaning to record a video like this, and I thought this was a good opportunity. So you can see I'm doing some TDD, some test-driven development. I've got my tests over here. Basically, I just had to copy and paste these values into a Go struct on this side. So, and I am at the red phase. So we're going to go for red, green, refactor. I've written a lot of things like this before, so probably I don't have to refactor too much. But we'll see. So the first thing I'm going to do, I just need to open. So I had my read input function. I'm having it take a string file name. So the first thing I need to do is actually get a file object out of that, or a file type, I guess. So we'll just do it like this. Do some classic Go error handling. For now, I'll just panic. Probably will always panic because this will be the first part of the problem. Okay, so you can see I am using lsp-mode, so I'm using Go please with lsp-mode in Emacs. I'm also using company mode. I also have Go import set up, so when I type Control C6, it will run Go imports along with GoFunt and import OS for me. Now I'm just getting a warning about this F being unused, but we are about to use it. What else? The Control C6 binding. I have a very small keyboard. I think it's, what is this, like 60% or something? So I don't have any function keys. So I have GoFunt bound to F6 usually, because I bind compile to F5. So I usually just hit F6, F5, and that formats my buffer and compiles it. I know you can set up GoFunt on save, but I don't really like that because I make a lot of small changes and then save immediately. Oftentimes in a state where GoFunt would complain at me. So I don't want it to do it on every save. I should probably bind it to compiling. Like when I compile, it just does the GoFunt, so I don't have to hit both, but it's not a big deal. But anyway, when I don't have function keys on this keyboard, I rebind those things to Control C and then the number of the function key. So I've got Control C6 to GoFunt and Control C5 to compile. Alright, so let's actually use this file. What does this return? I think it's like an IO read or something. os.file. Okay. Alright, so the way I usually parse files like this is I use a scanner. So, and I usually just call it scanner equals, what is it, IO new, whoops. Oh, it's been a while since I've done this. Scanner, is it buff IO? New scanner, there we go. On F, for scanner.scan. And for now we can just print the line. This is what I do a lot of the time. Print line, scanner.text. What? Okay, there we go. go imports is not working. Oh, do I not have go imports installed? Well, obviously I have it installed. Oh, all right. So that's one problem with the language server sometimes. So here it misidentified the problem. It's not the problem that funct is undefined. The problem is that println was undefined inside of funct. So it didn't identify this as a package. Okay, there we go. So this is what I typically do, is just print the lines. Alright, so now that we've got our basic loop set up, we need to actually start extracting things from it. So I usually just set up, well, let's see, usually I'll declare line as a string, and then I'll set line inside here. Okay, so now we're setting line, and then usually I just set up a big switch, because we've got a bunch of different cases we need to handle inside of the loop. So let's see, when we see a line that contains spectro, strings that contains line spectro, yeah, again, I often just print it. So good, now we just catch that top line. So when we see that, let's go ahead and make this a named value so that we don't have to initialize it. We'll just return that config. Okay, so when we see spectro, that means we need to start looking for lines of integers. So a new way I've been doing this is I will just let's do this. So a lot of the times we also want to split the line. So we can just do this on each iteration of the loop. Strings.fields line. Okay, perfect. Yeah, so what I've been doing lately is I'll set up like a handler. So let's declare a handler to just be like a function. Alright. And initially it'll be nil. Nil. We just call handler. And so then I can write the logic associated with each section of the input file together. So for example, and we can make it a function of like string. We can't really have it return anything because it's going to be doing different things depending on the section of the file we're in. All right. So let's see. What did I call that? Cards. So we'll just define cards handler to be a function, and it's going to take fields. Let's see, fields. All right. So basically, we're going to have this as a slice of string. So we're going to loop over that slice, and for each of the values, we're going to parse it. So I usually just call it v. We're going to ignore the errors for now. Strcon parse. Well, I usually use a to I for this. A to I. And then we'll just go ahead and append that to cards. So ret.cards equals append ret.cards. Cards handler. So now when we see line spectro, handler equals cards handler. Perfect. And then we can say also case strings.contains line. So when we finish with the spectro section, we're going to hit the geom section, handler equals null. So that way we don't keep trying to call the cards handler. So let's see. Alright, fantastic. And I'll go ahead and print this with a little more information just to make sure. Yeah. Okay, good. Alright, that's great. So one nice thing about doing it like this, I mean, we could even have this return things. If we really wanted to test like every element of this, we could define these as functions themselves, like outside of this function, and then we could actually test them directly. So for example, this could take fields as an argument, and it could return something. So it could like build this up and return it as well. And then we would know exactly what's coming in and out each iteration. So then we could test that directly. But I'm not too worried about that. I'll let my the test for the outer function handle it. Alright, so now we've just basically defined these handlers for each section of the input file. I'll actually copy and paste this. So now we want a geom handler. And here, handler equals geom handler. Let's go ahead and set up this whole section. We'll do all this at once. Alright, so we've got geom. We're going to have a wait handler. Wait handler. And we'll have a curl handler. When we see curl. Great. Alright, so when we see the geometry, we have to do a little bit more work because we need to make atoms. Let's see. So again, we need to parse the first element as an integer. I'm actually not sure if we can do that. Let's see. Go. Because they're in the input file as floats. I know in some languages it will parse the first part of the string like until it gets to something it can't parse as an integer, and it'll stop there and still give you the value. I think Go doesn't work like that though. So Go doc, how about strconv? Okay. I'm still having some issues with my D menu path. I need to update that. Alright, numeric conversions. Okay, parse int. Alright, A to I. Well, we'll give it a shot. We can always fix it if it doesn't work. Okay, so this time in range fields, so we have to handle these two different ways. We need to parse the first part. Okay. So I'm just going to grab a blank atom. Okay. And then atom dot type equals strcon. No, again, we're going to use A to I for this. Fields of 0. Okay. So we're going to parse this first element as an integer. And actually, let's just see if that works for now. Okay. Yeah, of course. We need wait handler, verbal handler. Uh-oh. What? it must be something like this. Alright, let's just set these to nil then. Oh, okay, that wasn't the problem. Ah, this was the problem. Alright, we can't use an untyped nil. Alright, let me undo some of this. So for those of you wondering, I should really have screen key on, but I've had a lot of trouble with screen key in the past. So what I'm doing to comment things out, actually, let's just try screen key. Let me pause the recording and install screen key. Okay, so that was a little more involved than I thought. I just filed a bug report on screen key because I think it's missing one of its dependencies in package build. When I first installed it, it just hung when I tried to open it with dmenu, and it's because it couldn't find the module dbus. So it should really depend on dbus Python. Once I install that, it seems to work fine. Alright, anyway, but the way I'm uncommenting stuff is with meta semicolon. You can also do Control X semicolon on to do one line. But if you have region selected, you can use meta semicolon. Alright, so let's see, where were we? Oh, good. What did I do now? Ah, yes. Okay. So, good. So we're back to compiling. Now we just have to finish implementing our Geon Handler. Let's see. Can I actually append this to Geon? Okay, so the screen key is a little bit annoying, but what can you do? Type 3. Type 3? Oh, okay. Let's see. Yes. Yeah, okay, of course. So it's parsing this one. 3, 1. Let me make sure I know what that is. I think I know what that is. I'm just making sure that it's safe to skip that line. I'm checking the manual for the Fortran version. Number of atoms specifies whether it's in units of angstroms or Bohr. Yeah, we can probably skip that line. So something I usually do, oftentimes things like this come up where there are, can I change the size of this? That's weird. Let's put it at the very bottom. Okay, much better. Yeah, so we're gonna go ahead and skip that line. So what I usually do here is I'll say case skip greater than 0, skip minus minus. So, and then I'll introduce var skip int, and then we can just manipulate that. So if I need to skip a line, I just say skip equals 1. So the first time I hit geometry, I'm going to say skip plus plus. Well, skip equals 1. Okay. And so now we see that there are only 3 atoms being returned. Now, strcom is apparently failing us. Yep. Okay, parsing this. Yep, that makes sense. Oh. Oh, hold on. I did the wrong one. This is the one I wanted to check. Yep, invalid syntax. Okay. Well, yeah. Okay. So, the two main ways I see of handling this are that we can either, my first thought is to use like a regular expression and extract the first part of the string. But probably the easier thing to do is just parse it as a float. Parse float 64, and then we will actually what doesn't like about this? Oh, it's saying I can't assign it to this, of course. E, and I'll discard the error again. Atom type equals int E. We'll see if that will work. I think that should work. Type 1, type 8, type 1. Okay. Yeah, so we'll just parse as a float and then convert to an integer. It's kind of lame, but it does work. Now, of course, we can't actually wrap this because that returns two values. We can't convert the error to an int. Okay, so after that, we can parse float f64. And now, since we're using an array for this, we can actually cannot assign cards. Oh, whoops. No, so I need Atom. Atom dot chord of I. Okay, much better. Okay, so that should be good now. Type 1. Okay. Yeah, so the one issue with comparing structs like this in your test is that it's not always clear where the issue is. So I could split this out and say, like, if not, like if cars doesn't equal want.cars, if geom doesn't equal want.geom, but that's going to be a lot of code. I'll do that at some point if I can't get the test to pass like this, but I think it should be easy enough to get them to pass. Okay. Let's see. So now we can just do wait handler. It should be pretty easy. It looks like we're going to want skip again. So we'll copy this. Skip equals 1. So this time we just want the second one. Well, we do need both of them actually, because you don't actually have to specify the weights of all the atoms. You can, like, I could change this to be this, just 2 and 3. So what we're gonna want to do eventually is set ret.weights of I to v, like that. So I is going to be strcon I a to I of fields 0, and v is going to be strcon a to I not a dot. Parse float fields 1. Now the problem is that ret.weights may not be long enough for I. And we actually want I minus 1 because all of the Fortran stuff is base 1, or index from 1. So we first need to check if it's long enough. And we actually want to check that it's long enough. Well, I think you can extend. Apparently not. Can I set the capacity? Alright, well anyway, what I usually do is I just say for length ret.weights less than I just ret.weights like that. Perfect. And so this is actually the behavior I want. So if it's not set, we're just going to let it be 0. And then, actually, you know what? Let's make it minus 1. Because that'll be easier to check than actually checking if the float is equal to 0. So let's just say, if it's not there, it'll be minus 1. And we'll use that as a special flag. So if the weight, later when we actually need to use the weight, we'll check if it's less than 0. And if so, I'll use the default weight. Because that's basically how this actually works. We could do that here, but that doesn't really seem... I'll do that in the future. And then the last thing we need to implement is just the curval handler. So right now I'm just storing these as a list of int, so that's very easy. We'll just append. All we have to do is make like a temporary int slice. And I can... Do I even need to do that? I think I do need to do that because I'm going to append it. So, for f in fields... whoops. And then at the end, I'm going to set ret.curvels just like that. And we pass the test. Okay. So that was just a look basically at how I do some Go programming inside of Emacs. Nothing too exciting today. Some things that I do want to do. I did install the tree setter package. I'm trying to do stuff like automatically generate tests from the function. Although I was realizing today that that's kind of the opposite of how test-driven development should work. So maybe that's not even a useful idea in the first place. It is useful. I've been deviating a bit from test-driven development. A lot of the times I start sketching the function itself, and then I go write the test. So in that case, it'd be really useful. But if I try to get back into stricter TDD. Maybe that's not as helpful. But anyway, so this is my take on a little input file parser, and that's going to serve as the basis for the rest of the project, basically. And hopefully you got to see a little bit of how I use Emacs and really Vim, because when I'm doing the text editing, it's really all about Vim. And maybe got a little insight into using Go in general. So anyway, thanks for watching. We'll get back to the actual Emacs series very shortly. I have probably before this one goes up, you'll see a video about the very basics of an Emacs config, setting up evil mode. Alright, so I'll see you guys next time.